48% of organizations have no controls on what external users can do inside Microsoft Teams. That number is from a 2024 Proofpoint survey, and it explains exactly why UNC 6692 built their entire operation around it. Let's talk about what actually happened here, because the press coverage is doing that thing where it says, sophisticated threat actor, and then doesn't explain what's actually sophisticated about it. The sophistication is not in the malware. The sophistication is in the delivery channel choice. Teams, not phishing email, not a watering hole. Teams. UNC 6692 is a threat group that Mandiant has been tracking. The attribution confidence and nation-state affiliation are unclear from the reporting, so I'm not going to speculate on that. What is clear is the operational pattern. They contact targets via Microsoft Teams from external tenant accounts that look like vendors, contractors, IT support, the usual social engineering playbook, and they use that trusted channel to get a user to install what they're calling the Snow malware suite. Snow is not one thing. It's a package. There are 3 components, and understanding what each one does is more useful than the name. First, there's a malicious browser extension. Second, there's a tunneler. Third, there's a backdoor. These are not accidentally bundled together. Each piece serves a distinct operational purpose in sequence. The browser extension is the first stage collection layer. Once it's installed in a Chromium-based browser, Chrome, Edge, Brave, whatever the target is running, it has access to session cookies, stored credentials, browsing history, and can intercept form submissions. This is not new as a technique. Malicious browser extensions have been a persistent problem for years. What makes this instance notable is the delivery mechanism that got it there, not the extension itself. The tunneler is where things get operationally interesting for defenders. A tunneler's job is to create a persistent, outbound communication channel that looks like normal traffic. It's designed to blend into the noise of legitimate HTTPS connections going out of your network. If your perimeter is focused on blocking inbound connections, which most traditional firewalls are still biased toward, a tunneler laughs at that. It's making outbound calls. It's using ports you've explicitly allowed. It might be using legitimate cloud infrastructure as relay points, which is a technique sometimes called living off trusted sites. Whether Snow specifically does that is unclear from the reporting, but it's the standard approach for this class of tool. The backdoor is the persistent access mechanism. Once the tunneler establishes the C2 channel, the backdoor is what operators on the other end use to execute commands, exfiltrate data, move laterally, or drop additional payloads. The backdoor communicating back through Teams infrastructure or Teams-adjacent channels is the part that should make your SIEM team sit up. Here's the concrete operational problem. Your perimeter controls almost certainly have Microsoft Teams traffic in an allow list, or at minimum a low suspicion category. You have to block Teams and you have a mutiny from every department that uses it for daily work. So you've essentially pre-approved a communication channel that UNC 6692 is using as their command and control backbone. Your firewall sees Teams traffic. It says fine. It moves on. The C2 session writing inside that traffic goes unexamined. This is the same category of problem as C2 over Slack, over Discord, over Google Docs. Attackers have been doing this for years. The technique is sometimes called C2 over legitimate web services or lots, living off trusted sites. The reason it keeps working is that defenders are slow to instrument the inside of these channels, and vendors have little incentive to make it easy to do so. Now, what can you actually detect? Bleeping computers reporting references some indicators of compromise, and this is where I want to give you something actionable rather than just threat narrative. On the network side, look for unusual outbound connection patterns from hosts that don't normally initiate high-frequency Teams API calls. A developer workstation that's suddenly making sustained, regular connections to Teams endpoints at odd intervals is worth investigating. The regularity is the tell. C2 beaconing tends to be periodic in a way that human Teams usage isn't. If you have net flow or packet capture at your egress points, beacon detection queries on Teams-destined traffic are worth running. On the endpoint side, look for browser extension installations that weren't pushed through your MDM or extension management policy. If you're running Chrome Enterprise or Edge with extension Allowlisting, a Snow-style extension can't install silently. If you're not running extension management, and a lot of organizations aren't, especially for personal devices that access corporate resources, you have a gap. The extension will show up in the browser's extension list, but users don't look there, and most EDR tools don't alert on extension installation by default. Check your EDR vendor's documentation on whether you can write a detection rule for new extension installation events. Many can, most customers haven't. For your SIEM, the specific IOCs from this campaign, file hashes, domain indicators, extension ID, are in the Bleeping Computer article and should be hitting threat intel feeds within the next few days if they haven't already. Pull those and get them into your detection layer. Beyond the specific IOCs, the behavioral pattern to encode is external Teams contact followed by file download or browser modification on the same host within a short time window. That correlation across your Teams audit logs and your endpoint telemetry is the detection you want. Speaking of Teams audit logs, are you collecting them? Microsoft 365 audit logging for Teams is not on by default in all license tiers. You need to verify that your tenant is actually capturing external message events, file shares through Teams, and guest access activity. If you're on E3 or above, you should have access to this through the Purview Compliance portal. If you're on a lower tier, check what you actually have. Gaps in Teams audit coverage are common, and they matter here because without that log source, you're blind to the initial contact phase of this attack. The guest access and external access configuration in Teams is the other thing worth auditing right now. Microsoft gives you two separate controls that people often confuse. External access lets users in your tenant communicate with users in other tenants. Guest access lets external users join your tenant with a guest account and participate in specific teams and channels. Both are potentially relevant to this attack vector, and both have settings you can tighten. You can restrict external access to specific domains, a whitelist of known partner tenants, rather than allowing communication with any Teams tenant globally. For most organizations, the open default is not something they've made a deliberate decision about. It's just how it's shipped. One more thing on the social engineering angle, because I think it gets undersold in the coverage. The reason Teams works as a delivery channel is not just technical. It's psychological. When someone gets a Teams message, the mental model is colleague, or at least vetted business contact. Email phishing has trained people to be suspicious of unexpected emails with links or attachments. Teams hasn't built that same suspicion yet. An external contact in Teams asking you to install something for a meeting or a shared workspace feels lower stakes than an email asking you to click a link. That gap in user intuition is what UNC 6692 is exploiting, and no amount of perimeter tooling fixes it without also fixing the user mental model. So here's what you can actually do this week. First, pull your Team's external access configuration and make a deliberate decision about whether open federation is appropriate for your organization. If you have a defined set of partner tenants, whitelist them and block the rest. Second, check whether browser extension management is enforced on your corporate devices. If it isn't, that's a policy gap worth closing. Third, verify that Teams audit logging is active in your tenant and that those logs are flowing into your SIEM. Fourth, take the IOCs from this campaign and get them into your detection layer before the next variant shows up with different hashes. The real story here is not that a new malware family exists. New malware exists every week. The real story is that trusted collaboration infrastructure is a detection blind spot for most security teams, and attackers have noticed. Snow is one example. It won't be the last.